Good day. In study unit 5, we are going to look at chapter 11, which is on hypothesis testing for two populations. In chapter 10, we looked at hypothesis testing for one population when we tested the mean for large samples and small samples and for the population proportion. Now in chapter 11, we focus on two populations. So we are going to test the difference between two population means or two population proportions. For means, you should distinguish between large samples and small samples. And then for all three types, you should know when to apply which test statistic. In study unit 5, you should know the 5 steps of hypothesis testing, and you should be able to distinguish between left-sided, right-sided and two-sided hypotheses, and then you should be able to perform these through hypothesis tests. In chapter 11, we are going to use the same hypothesis testing procedure as in chapter 10, so we will again apply these 5 steps. In the first section, we are going to look at the difference between two population means. So in the null hypothesis, we specify that there is no difference between the two population means, or equivalently that the population mean for population 1 is equal to the population mean for population 2. It's important in a test and exam that you specify the meaning of me1 and me2 in the context of the problem. In the alternative hypothesis, we can either test a left-sided alternative hypothesis, where we state that me1 is less than me2, or a right-sided alternative hypothesis, where we state that me1 is greater than me2, or a two-sided alternative hypothesis, where we test that the two population means are not equal to each other, or they differ. We use large samples when both the sample sizes that you draw from the two populations that you are testing have more than 30 elements. The test statistic for large sample sizes are given by this formula, but under the null hypothesis we specify that there is no difference between the two population means, so we can simplify that formula to this. Above the line you then have the difference between the two sample means, and then below the line you have the square root of the sum of the sample variances over the two sample sizes. Please take note in a test or exam whether the question states that you are given the sample variances or the sample standard deviations. Because if you are given the sample variances, you can just plug in those values, but if you are given the sample standard deviation, then you still need to square those values. And then Z follows a standard normal distribution, so that means that we will use the Z table to determine the probabilities in step 4. For example, in example 11.1 on page 296, they state, a study is done to estimate the difference in salaries of teachers in private and government schools in a specific education community. A random sample of 100 teachers at private schools showed an annual mean salary of 105,000 Rand with a standard deviation of 15,200. That means that our N1 is going to be 100, our X1 bar is going to be 105,000, and S1 is going to be 15,200. So it's the standard deviation that's given, so in your test statistic you will still need to square that value. Then for the second population, they tell you they drew a random sample of 200 teachers from government schools, and the mean was 88,000 Rand with a standard deviation of 13,500. So that means that our N2 will be 200, our X2 bar will be 88,000, and S2 will be 13,500. Then they ask you to test the hypothesis that the mean salary of teachers in private schools is higher than that of teachers in government schools. So in the alternative hypothesis, we will use greater than. and then they ask you to test this at a 5% significance level, so alpha will be 0.05. In step 1, we specify the null and the alternative hypotheses. So in the null hypothesis, you will state that μ1 is equal to μ2, and in the alternative hypothesis that μ1 is greater than μ2. Remember to specify what μ1 and μ2 represents. So we can define μ1 as the population mean for private schools and μ2 as the population mean for government schools. Step 2, you write down the formula for your test statistic and you indicate the distribution of that test statistic, and you also give your significance level. Then we can substitute the sample data in step 3 to determine our Z value, and that will be 9.471. Then we can use that to calculate our p-value in step 4. So our p-value will be the probability that Z is greater than 9.47. However, if you look in your Z table, you will see that the largest value in your Z table is 3.09, and the probability to the left hand side of that is 0.9990, and that will make the probability to the right hand side of 3.09 0.001. But since I don't have that value in the table, I can just use the largest one in the table then. And because that value is further to the right hand side on that number line, this probability will even be less than the one to the right hand side of 3.09. So we can just say that our p-value will be less than 0.001. So that will be approximately 0. Then if you compare that to your significance level, p will be less than alpha. So we can reject the null hypothesis. And if we reject the null hypothesis, it means that the alternative will be true. So the mean salary for teachers in private schools will indeed be higher than that of teachers at government schools. In example 11.2, they give you the descriptive statistics for a survey conducted among two types of commuters. So these were the values for the train commuters and these were the values for the bus commuters. So again, your sample standard deviation was given and not the variance. So we will need to square those values in our test statistic. Then they ask you, test the hypothesis that the travel time for train commuters is shorter than the travel time for commuters traveling by bus. So that means that we will test a left-sided alternative hypothesis. And then they say that you should use a significance level of 0.1. So in step 1, in our null hypothesis, we state that μ1 is equal to μ2, and in the alternative that μ1 is less than μ2. We can define μ1 as the population mean for train commuters and μ2 as the population mean for bus commuters. Step 2, write down the formula for your test statistic, you give the distribution, and you write down your significance level. We can then calculate the Z value in step 3. Remember to square the standard deviation value since we need the variances. And our Z value will then be negative 2.396, or if you round that off to 2 decimals for the Z table, it will be negative 2.40. Our p-value will then be the probability that Z is less than negative 2.40. We already have that area to the left hand side of a negative Z value in our negative Z table, so you can just write down that value. If you compare that to your significance level, p will be less than alpha, so we can reject our null hypothesis. So that means that the travel time for train commuters is shorter than travel time for bus commuters. You can then try exercise 5 on large sample means, please. The next section looks at hypothesis testing for the difference between two population means, but here we work with small samples. So we can apply this when either of our samples contain 30 or less elements in them. We usually assume normality, but this refers to the population data. But we will use the t-table to determine the probabilities in step 4. And because our t-distribution approximates the standard normal distribution as our sample size gets larger. Then we also assume that the population variances are equal because the spread for the two sample sizes can differ a lot, since the sample sizes doesn't need to be the same size. The test statistic that we use for small sample sizes is given by this formula, where t follows a t-distribution with these degrees of freedom. So you take your first sample size plus the second one minus 2, since we are working with two samples. And if you look at this SP value below the line, we call that the pooled standard deviation. And it's like a common standard deviation measure for the sample data for both populations. The formula for SP is given by this, where N1 is your first sample size, N2 is your second sample size, and then S1 squared represents the variance for the first sample, and the second value is the variance for the second sample. So if the standard deviation is given, you need to square those values. You will see in the textbook they give you the SP squared value, which is the pooled variance, but I already square rooted it when I calculate the values on the slides, because we need to substitute the SP value and not the SP squared value. In the first example on this, in example 11.3, they took two samples and they said that the first sample contained 11 elements and the second sample contained 14 elements. And then they give you the descriptive statistics. Just take note that they give you the standard deviations, so when we calculate SP, we need to square those values. Then they asked you to conduct this hypothesis test. So they stated step 1 for you already. And then they say assume that the population variances are equal, and they give you a significance level of 0.01. We are going to test a two-sided alternative hypothesis then, since it was stated in the question, and they didn't identify μ1 and μ2, so we can just define μ1 as the population mean for population 1 and μ2 as the population mean for population 2. Then we can write down our test statistic, and t will follow a t-distribution with 23 degrees of freedom because our n1 was 11, n2 was 14, and we subtract 2 from 25 then. And then we write down the formula for SP and our significance level. Then we need to calculate SP first of all in step 3, because we need that to calculate t. We can then substitute that and our sample data, and then our t value will be 2.438. Since we are conducting a two-sided alternative hypothesis, we are going to look at the probability that t is less than negative 2.438 plus the probability that t is more than positive 2.438. But since we only have a positive t-table, we can write that as 2 times the probability that t is greater than 2.438, since this area and the area to the left of a negative t value will be the same as the area under the curve is symmetrical. Now, if you look up that t value in your t-table at a degrees of freedom of 23, you will see that it's not in your t-table. So we need to apply the interpolation formula from chapter 8 then, since our t value will lie between these two t values, and the probability will consequently lie between those two probability values. So if you substitute the values from your t-table, our p-value will be 0.023. If you compare that to your significance level, your p-value will be larger than alpha, so we do not reject the null hypothesis and we can make the conclusion that there is no significant difference between the population means. In example 11.4, they show you the waiting times of clients at a certain bank branch in a business area and a residential area, and they ask you to test at a 5% significance level if the mean waiting time at the bank in a business area is shorter than the mean waiting time at the bank in a residential area. So our significance level is going to be 0.05, and we are going to test a left-sided alternative hypothesis, so our sign will be less than. And they say assume equal population variances and normality. Both of the samples have 11 clients in them, so both are small samples, so we can use the t-test statistic in this problem. They didn't give us the sample means and the sample standard deviations, so you can calculate that for the first sample and for the second sample. In step 1, you state your hypothesis then. So in the null hypothesis, μ1 will be equal to μ2. In the alternative, μ1 will be less than μ2. Then we can define μ1 as the population mean for the business area bank and μ2 as the population mean for the residential area bank. Step 2, you write down the formula for your test statistic, and t will follow a t-distribution with 20 degrees of freedom, since 11 plus 11 minus 2 will give us 20. Then we can also give the formula for SP and our significance level. Then you can substitute your sample statistics to calculate SP. You need to square those values since we determined the standard deviations for our samples and not the variances. And then we can use that and the other sample statistics to calculate our t value. So t will be negative 4.942. Our p value is then the probability that t is less than negative 4.942. But I don't have a negative t table, so we can rewrite that as the probability that t is greater than 4.942. Since that area and that area will be the same under the curve, since our area under the curve is symmetrical. But I only have the values to the left hand side in my t table, so to get that area I can write that as 1 minus the probability that t is less than 4.942. However, if you look in your t table, you will see that the last value at the degrees of freedom of 20 is a probability value of 0.995, and that will be to the left hand side. So the probability to the right hand side of 2.845 will be 0.005. Since I don't have that value in my table, I can then just write that the probability will be less than 0.005, since that area will even be smaller than the area to the right hand side of 2.845. And if you look at the computer output in stat 1.3, you will see that that probability will be indeed be less, because it will be 0.00004. And then our p value will be less than alpha in step 5, so we can reject the null hypothesis. So we can make the conclusion that the mean waiting time at the bank in the business area will be shorter than the mean waiting time at the bank in a residential area. You can then try exercise 2 on small sample means, please. In the last section in chapter 11, they look at the difference between two population proportions. In the null hypothesis, we will then state that there is no difference between the population proportions. So pi 1 will be the same as pi 2. Then pi 1 represents the population proportion for population 1, and pi 2 represents the population proportion for population 2. So again, it's important that you write down what pi 1 and pi 2 represents in the context of the problem. Then we can again state a left-sided, right-sided or two-sided alternative hypothesis. So in the left-sided alternative hypothesis, you will state that pi 1 is less than pi 2. In In the right-sided alternative hypothesis that pi1 is greater than pi2, and in a two-sided alternative hypothesis that pi1 is not equal to pi2 or different than pi2. The test statistic for population proportions is given by this formula, but under the null hypothesis we state that there is no difference between the population proportions, so we can simplify that formula to this. So above the line you have the difference between your two sample proportions. So in chapter 9 we saw how to calculate that. It will simply be x divided by n for each of the samples. And then below the line you have a p-hat value, and this is calculated with this formula. It's called the pooled sample proportion, and it's a common proportion that we calculate for the sample data that was selected from the two populations. And then your test statistic follows the standard normal distribution, so we will use the Z table to determine the probabilities in step 4. An example of this is given in example 11.5 on page 302. There they tell you, in a survey of 175 customers, 60 indicate that they will buy Corn Bix breakfast cereal if it is available in the shops. So that means that our N1 is going to be 175 and X1 is going to be 60. So you have to calculate the sample proportion yourself. So for this first sample, 60 divided by 175 will give you 0.343. Then they tell you that 40 out of 150 customers say that they will prefer Flake Bix. So your N2 will be 150, X2 will be 40. So our sample proportion for the second sample will be 40 divided by 150. That will give you 0.267. Then they want you to test the hypothesis that Corn Bix is more popular than Flake Bix. So in our alternative hypothesis, we will look at a right-sided alternative hypothesis. So our sign will be greater than. And they say use a significance level of 0.1. In step 1, we state our hypotheses. So in the null hypothesis, pi1 will be equal to pi2, and in the alternative, pi1 will be more than pi2. We can define pi1 as the population proportion for Corn Bix and pi2 as the population proportion for Flake Bix. Step 2, you write down the formula for your test statistic. You give the distribution of the test statistic and the formula for p-hat, and our significance level was 0.1. Then you need to calculate p-hat first of all in step 3, because you need that in Z. So p-hat, if you substitute your sample data, that will be 0.308, and then you can substitute your sample data to calculate Z and then the p-hat value. So Z will be 1.479, or rounded off to 2 decimal places for the Z table, that will be 1.48. Our p-value will then be the probability that Z is more than 1.48. We only have the values to the left-hand side of a positive Z value in our table, so 1 minus the probability that Z will be less than 1.48 will be 1 minus that probability that you look up, and P will then be 0.0694. And if you compare that to your significance level, it will be less than alpha. So you can reject your null hypothesis, so we can conclude that Corn Bix is more popular than Flake Bix. You can do exercise 3 then to practice population proportions, please.